Define a catalyst. A catalyst is a substance that alters the rate of the reaction by altering the mechanism but not undergoing any chemical change itself. Another definition that you need to know. Fully explained by referring to the collision theory, how catalysts increase the rate of a reaction. They alter the mechanism. So it's an explanation now where you actually need to say that it is the mechanism that is changed, and therefore allowing for the reactions to, or the molecules to be orientated in such a way to be more effective. So it's got to do with the orientation of the molecules. The reaction for the decomposition of hydrogen peroxide is given below. The decomposition is a slow process, but it can be catalyzed. Students are asked to investigate 3 different catalysts, and they are given there. You've got manganese dioxide, lead oxide, and iron oxide, or iron 3 oxide. They were asked to rank the catalysts. So this is what you have to do. Rank the catalyst. Not just good enough to say what is the best catalyst or what is the worst catalyst. You've got to rank all 3 in terms of how quickly they bring about the decomposition. So what is a suitable investigative question? You can say which catalyst makes the decomposition of hydrogen peroxide go fastest and which goes slowest, or a better one might be what is the rank order of the following 3 catalysts in terms of their effectiveness in the decomposition of hydrogen peroxide. One of the students suggests that they need to repeat the experiment at least 3 times. Why is this suggestion important? It ensures accuracy and precision and therefore results in reliable data. And that's what you want. You ultimately want a reliable data so that you have got a fair test. This is what you get out of it. So the data is given there. Calculate the average time for manganese dioxide. So that's your manganese dioxide. 4.8 plus 5.2 plus 5.4 divided by 3 gives you 5,13 seconds. It's a time. Name the compound Fe2O3. It is iron, clearly. It is oxide, clearly. But it's got some sort of stock notation because iron is in the transition element. So I'm going to put iron here. I'm going to put 2 of them there. I'm going to put 3 oxygens. I know oxygen has 2 arms, and therefore each of these ions must have 3 arms in order to hold hands. So to get the marks, it is iron 3 oxide. Comment on the precision of the readings of time when lead oxide is used. How should this be corrected in the experimental procedure? So lead oxide, there appears to be a problem with the second reading. So the second reading seems imprecise. So the best way of doing this is to repeat the experiment one more time so that you can have 3 precise readings. Remember what precise means? That your readings are close together. Accurate means that they are correct. Another experiment during the decomposition of hydrogen peroxide, students measure the concentration of hydrogen peroxide every 200 seconds. The results are shown in the table below. So this is what I decide on. So that would be my independent variable. And I check the concentration every now and again. And I get that as my dependent variable. Calculate the average rate of decomposition. And there it is moles per cubic decimeter per second. So I'm going to take a change in my dependent variable and divide it by a change in my independent variable and see what I get. I want the average rate, so I want start to end. So I am going to go 0,02 minus 0,086, and I am going to divide that by 800. And it's for the first 400 seconds, so I'm going to use 0,02 minus 0,0131, and I'm going to divide that by 400 seconds. The change in concentration over the change in time will give me moles per cubic decimeter per second, and I find that I land up with an answer of 1,73 times 10 to the negative 5 And there's my unit over there, moles per decimeter cubed per second cubed. Will the rate of decomposition at 600 seconds be greater than, less than, or equal to the average rate, and why? It's going to be less. And why? Because the concentration of hydrogen peroxide has decreased, and that's probably enough for just 2 marks. If they wanted a full explanation, you could therefore say there are therefore less hydrogen peroxide particles to react, and therefore there are less effective collisions, and less effective collisions means a slower rate. Into organic chemistry, we've got all of these stories over here, and we've got a reaction which is a combustion reaction, where I've got an alkane, and it happens to be propane, combustion, and I react it with oxygen to get carbon dioxide and water. I then have a carboxylic acid in B, carboxylic acid reacting with an alcohol, and we know that that gives me an ester and water. In C, I've got a double bond becoming a single bond, so that is an addition reaction. And in fact, it's a special addition. It's a hydrohalogenation. Because I'm adding hydrogen, halogenation. And I'm adding bromine, which is a halogen. I have another addition reaction in number 2, but it's a specific one. It forms an alcohol. We're going to open up that double bond, and we're going to get an extra hydrogen and the OH group onto that. So I'm going to form an alcohol from that. And finally, I have a hydrogenation reaction. Again, double bond is going to be broken, and I'm going to land up with a single bond, and I'm going to land up with pentane instead of what I started with, which was pentene. Identify the reactions in B and C. We've just discussed it. It's an esterification. And a addition, but it would be even nicer if you wrote hydrohalogenation addition. Draw the structural formula for compound 2, which is the major product of reaction D. Reaction D, remember, formed an alcohol. So if I have to draw that out, I'm going to go, it had 5 carbons to start with. And then I'm going to get the alcohol group on the end where the double bond was. State the IUPAC name for the products of formed at 1 and at 3. So it's of reaction C and reaction D. So first we want this particular one, which we know was pentanol. And that's number 2. And number 1 is 2-bromo, 2-methyl, propane. And that's when we open up that double bond. There will be a bromine and a hydrogen put on there. To which homologous series does compound number 3 belong? Compound number 3 is going to be, remember it was the hydrogenation reaction, so we start with an alkene and we end with an alkane. Considering just reaction B, which was your esterification, what are the names of the reactants? And the first one had 2 carbons, so it's ethanoic acid. And the second one has got 3 carbons and it's an alcohol, so it's propanol. Write down the full structural formulae for the products in the reaction B. So I'm going to want to put the ester and the water. Okay, you'll remember that the acid is always going to form the part that's got the double bond O. So eth is 2, propanol, 3 carbons there, and my water is the angular molecule that we know water to be. Finally, write down the IUPAC name of this ester. It's going to be the alcohol first, so it's going to be propyl ethanoate.